Hey guys, I'm gonna try to attempt to give you some videos of calculus lessons so you can pause and look at examples and learn at home. So Larry, I know this is not as good as the Khan Academy guy, but it's me, so you can feel like you're in class. All right, so 8.1, we are looking at integration techniques, all different types, and we're going to be creative. But I'm going to provide you some structure on how to look at things so that you can use your different techniques to take the integral of things. So the first thing to look at is polynomial division, or kind of like things that related to a polynomial divided by a polynomial, and then see what we can do about it. So for example 1, we say if you have the integral of x to the third minus 4x plus 1 all over 3x, and then we are taking the integral with respect to x. So it looks like we have a polynomial divided by a monomial. So we can just go ahead and do the division. The hope is that you will get something smaller and easier to take the integral of. So let's just divide. So x to the third divided by 3x is going to be x squared over 3. That's x to the third divided by 3x minus 4x divided by 3x. The x will cancel, so you'll just have 4/3 plus 1 divided by 3x is 1 over 3x dx. And as you notice, you can take the integral of each one of these terms. So that would be the integral of x squared over 3 would be x to the third over 9. That's because you're supposed to divide it by the 3, but there's already a 3 there, so you have a 9 minus the integral of 4/3 dx would be 4/3 x plus the integral of 1 over 3x. We can think of it as like 1/3 multiplied by 1 over x. So then the integral of 1 over x is ln of absolute value of x, and then you have the 1/3 in the front. And don't forget the plus c. Okay, how does that look? Pretty awesome, right? Polynomial divided by monomial. Just go ahead and do your division, and you get simpler terms, then you can integrate. Okay, I'm going to give you another example. You might say, oh hey, that's kind of easy. Well, give me a harder one. Sure, I'll give you a harder one. Okay, so let's say if we have the integral of x squared plus 3x plus 1 divided by x plus 4. Oh, that's not a monomial. So what are you going to do? Well, you're going to have to go back to college algebra, and you are going to do long division. And if you haven't done college algebra in a while, or haven't seen long division for a while, it's not too bad. It's like maybe 2nd grade, 3rd grade. Long division, how do we do that? we write this, right? Because that's a division sign. And we put a thing here, x squared plus 3x plus 1. And we are dividing by this thing here, so we're going to put this thing over here, x plus 4. And we're just going to divide. Okay, so how do you do that? You just say, well, if I have this, what do I put right here to multiply to this to give me x squared? Well, of course, that's an x. Because x times x is x squared. And we know in long division, after you put a number up here, you multiply and then you subtract. So x times x is x squared. And distributive property applies, so you have to also take x and multiply by 4. That's plus 4x. And then what are you supposed to do after you multiply and you put it here? Yes, you are going to subtract. So that would be minus. Okay, so then you will have x squared minus x squared. That's gone. 3x minus 4x is negative x plus 1. Carry down the 1. That's how it goes, right? And then you look at this and you will say, well, I have x here. Can I have a number multiplied to x to give me negative x? And yes, that number is negative 1. So we have negative 1 times x. That's negative x. Negative 1 times 4. That's negative 4. And what are we supposed to be doing? Subtracting. So that means change the sign here. And we have, well, what do we have? That's gone. And we have 5. 5. That's what it is, right? So you go back to your integral and you say, well, you know what? My integral that I had before, this right here, is the same as the answer, well, plus the remainder. You can't just write plus a remainder. It doesn't really make sense. You can't just be like in grade school right now and write R5, because R5 makes no sense, right? So write that R5 as a fraction. What fraction are we talking about? We are talking about plus 5 over x plus 4. The remainder over the things that you're dividing by. Okay, so my integral right here will become, the answer would be, actually the simpler version of this is the integral of my x minus 1 plus 5 over x plus 4. Okay, so I'm going to go ahead and erase this part here so I'll have room to take the integral. And we are taking the integral of that with respect to dx. Okay, so take the whole thing here on the top, divided by x plus 4 using long division. It gives you this integral. And the integral now of x is going to be just x squared over 2. We know that, right? And then the integral of 1 dx is x. Then the blue part right here, the integral of 5 over this 1 over x, the integral of 1 over x is ln x. So think of a mental u substitution right here. Let u be x plus 4, so that will be just, 5 ln of u, or ln of absolute value of u, in this case 5 ln of absolute value of x plus 4. And again, don't forget your plus c. Okay, so how do we go from this part to this part right here? Long division. Long division. And that is that for polynomial division. Now, another thing that is related to this long division or polynomial division is this right here. I'm going to give you an example and you can see how that works. Let's say if you have something like this, integral of, so here's an example that is not in your guided notes, but I wanted to add it on here so that you can see the integral of sine x plus 1 all divided by cosine of x dx. Well, do you see how it looks kind of like a polynomial divided by a monomial, like on the first example, right? So in this case, we can go ahead and take each individual term here and divide it by cosine of x. So that would equal to the integral of sine x over cosine x. And I'm going to write them separately this time because it's easier to think. But plus the integral of 1 over cosine x dx. Now, this one I want to keep as just sine x over cosine x, because if I let u be cosine x, then du is sine x dx. So this is of the form integral of 1 over u du, which give me ln of cosine, absolute value of cosine of x. Now I think we dealt with this one before, right? So I'm just gonna not talk about that. This one right here, instead of saying 1 over cosine x, I am going to call that secant of x. 1 over cosine x is secant of x. And we have seen in class way long ago, maybe about a week ago or so, maybe, we had a really cool trick where we multiply that by secant x plus tangent x and secant x plus tangent x, right? So we multiply by 1 right here, and that's our 1. And then that becomes the integral of secant square x plus secant x tangent x over secant x plus tangent x dx. Then again, this is another u substitution where this denominator is your u and the numerator right here is your du. This was your u, this is your du right here. Because the derivative of secant is secant tangent, derivative of tangent is secant square. So that's your du. So the integral of 1 over u du is, again, ln of absolute value of u, which will give you ln of absolute value of secant x plus tangent x. And you want to say plus c. Don't forget the plus c. That is your answer for this problem. And this in structure look like polynomial divided by a monomial. So you write them separately. And you take the integral individually to get there. Does that make sense?